So, good morning, everyone. Myself is Dr. Ajit Kumar. I am the Assistant Professor at Presidency University in the Department of EC. So, we'll start our second second lecture of the first module. So, we're discussing about the 8051 microcontroller. Today, we'll discuss about the architecture of 8051. So, before I discuss about the architecture of 8051, we'll discuss something which is related to the assembly language programming. So let us try to see our different languages which we are using in the assembly language. Sorry, different languages for the programming. So here, so here broadly we have two types of languages. Okay, we have two types of language. So here we have two types of language. Okay. So here we have language, programming language is programming language. Is basically of two types. One is called high level language. One is called basically low level language. Another one is called high level language. High level language. Now here the processor understand our low level like this. The processor understand only processor that we are using. Okay, processor understand only low level language. This in this case, what is this low level language is basically a language which is composed of zeros and ones. Okay, that is when you write the program in the form of zeros and ones. So our processor understands only 0 and 1. Basically, what is this 0 and 1 is? We know that this 0 is low volt electrical signal, maybe 0 volt electrical signal, and this binary one is high volt signal, let's say 5 volt binary signal. Okay, so I mean 0 volt, 0 volt means we have no voltage at all. 5 volt pulse means something like this. Okay, so when we are giving this 0 volt, 5 volt, so we know actually where it comes is from the, let us try to understand from the gate point of view. We people have studied about the different gates. Let's take this AND gate. So we know this AND gate is there and we have inputs A, B, let us say input is A and B and we are getting the output Y. So we understand the logic of this AND gate is, we already know the logic of AND gate, that is if both are 0, the output is 0, if it's 0, 1, then 0, if it is 1, 0, then 0, if it is 1, 1, then it is 0, sorry 1. So basically what this gate is, actually, or from what device it is manufactured. Now this gate is manufactured from transistor. Okay, this is fabricated from transistor. Now look, here we are giving 0 and here we are giving 0. So basically we are giving 0 or 1 binary numbers to this transistor. Now what is the significance of this 0 and 1s to this transistor? Transistor is a semiconductor device. This is a semiconductor device. Semiconductor device has only one purpose, that it will conduct the current. It doesn't do any other thing. Then what is this 0 and 1, 0, 0 we are giving? Do this have any physical significance? The significance lies here that this 0 and 1 are actually high volt and low volt electrical signal. Okay. So if you are giving here 0, it means that you are giving 0 volt. If you are giving here, let's say binary 1, then it means that you are giving here 5 volt electrical signal. 0 volt and high volt signal. So this is, and this is just one gate that I gave example. Okay, and you also know that there are many other types of adder circuit. For example, add half adder circuit that we have studied is, half adder circuit. Already we are knowing half adder circuit, how it is implemented. You know that sum is given by A XOR B, and carry is given by AB. Just you can have here this one. Okay, you can have this A and B as input, and let's say sum and carry as output. So 0 0, sum is 0, carry 0. 0 1, sum is 1, carry 0. 1 0, sum 1, carry 0. 1 1, then we have sum 1, carry 1. Okay, so from here you can find the expression of C. C is AB and sum is here, I think here it will be 0, sum is 0. So our sum is 1, 1 here. So let us take the sum of product from SOP. So in that case, here it is A0 and it is B1, so it is A bar B. Okay, plus here for this output one, the A is 1 and B is 0, so it is A B bar, and this comes at A XOR B. So to implement this A XOR B, you know what which gate is required, that is XOR gate is required. So if you draw one XOR gate here and give inputs A and B, okay, then we'll get here sum. Similarly, if you take AND gate and take the input, then you'll get carry. So my point is, if you want to implement this half adder circuit also, in that case you are using gate. Gate means transistor. Transistor means semiconductor device. Semiconductor device can conduct high volt or low volt electrical pulse. Okay, high volt is binary mapped to binary one, low volt is mapped to binary zero. So that is why, you know, inside the processor we have millions of such gates. Okay, millions of such gates which does this addition, subtraction, multiplication, division. Okay, all those circuits are performing or doing computational tasks which are inside the processor, any microprocessor. Fine, so obviously that is why I'm saying that this microprocessor understands only 0 and 1. Okay, and 0 and 1 is only understood by this microprocessor. So in that case, if 0 and 1 is understood by this processor, so any what I was saying is programming language. Okay, so when we write our language in the form of zeros and ones, then it is called machine language. Machine language. Okay, a language which is written in the form of zeros and ones is called machine language, and this machine language comes under the category of low level language. Okay. Now, here we have, now what is the problem is that if you user or people like us wants to write the program, for us it is difficult to remember the streams of zeros and ones. Okay. For example, let's say okay, suppose that I have to add 0 and 1 here. Okay, so if I want to add 0 and 1, so suppose that I have to add two numbers. Okay, two numbers here. So adding two number, for that purpose you have to write program. Okay, or if you want to add these two numbers, then you have to write program to perform this task. So in that case, here if you are going to write program using zeros and ones, it is difficult to write the program. Okay, now what is there is we have a code here. Okay, we have code here. Okay, we have code here. Now these codes are actually okay. These codes, suppose that you have to add, let's say 4 and 5. Okay, let's say simple addition of 4 and 5. Now, as I said, that your microprocessor will not understand this 4 and 5 because they are decimal number system. Okay, so this decimal number system is first of all converted to binary number system, that is 0 1 0, and this 5 is written as 0 1 0 1. So suppose that you have to perform this addition. So for this purpose, you are going to write program. Now in the program, we know that we have instructions, and instruction is basically the code that we are telling here. Okay, so to perform this addition, you know that after adding 0 plus 1, 1, 0 plus 0 is 0, 1 plus 1 is 0, carry 1, and then 1. So this is the output. Okay. However, to perform this addition, you have to write the program. For that purpose, we have code also. For example, let's say 0. I mean, just I'm taking one. Assumption that 0 1 0 1 0 1 0 1 2 3 4 5 6 7 8. So let us say this is the code for addition. Okay, I mean, and the number which you are going to add is 0100 and 0101. Okay, these are the number that you are going to add. So this is 4, this is 5. Now this 4 is having this binary, this 4 is having this binary code, and 5 is this binary code, and this is the code of addition. So in that case, you will have to write something like this, that 0 0 1 0 1 0 1 0, and then followed by this, the number 4 and 5, that is 0 1 0 0 comma 0 1 0 1. So this is complete code or instruction to add to add 4 and 5. Similarly, there might be some different codes for the subtraction, okay, which is composed of again zeros and ones for the subtraction, and then for the multiplication also we have another unique code. Okay, like this we have different combination of zeros and ones, which actually is called code here, okay, or opcode. Now the problem is that we people cannot remember these streams of zeros and ones, which are actually called code to perform addition and subtraction. Okay, this is quite difficult. So that is why there is another language which is called assembly language. Assembly language, okay, is actually little bit higher. Okay, this is higher than machine language. This is higher than machine language, but it is not under the higher level language. Okay, this is also under the low level language only. Low level language only. This also comes under the category of low level language only, but it is higher than machine language. Now here in the case of this assembly language, we assign mnemonics. Okay, we assign mnemonics here, mnemonics to these codes. Okay, for example, this 0 0 1 0, okay, 1 0, which I was assuming it is for the addition. For this we are assigning a upcode, something like this, ADD. Okay, so this is mnemonics, MMNEMONX, this one, mnemonics. So this add is just, I mean, you can say English, I mean, combination of English alphabet letters, which is actually now easier to remember. Okay, you can just write ADD, which will be doing the addition. Okay, similarly, we have another code, okay, for the subtraction. Let's say this 0 1 0 0, whatever that is. So it will be like the mnemonics for this one is SUP. Similarly, other binary codes is having another mnemonics for multiplication and division. Okay, so this ADD is the mnemonics for addition. This SUP is the mnemonics for subtraction. MUL is the mnemonics for the multiplication. Okay, now it is easier to write the program in this by using this mnemonics. Okay, now here, let's say that you are going to add two number again. Let's say 4 plus 5. Okay, so what we'll do is, I'm assuming that you are knowing a little bit about uh, um, any other processor, let's say 806. Okay, in 806. So let us say, what I'll do is I'll write something like this, move. Okay, I'll discuss about this move and these things later on when I'll discuss about the instruction set of 8051. So I'm just giving the example of 806 microprocessor, not the microcontroller 8051. For that I'll come, okay, later on. So I'll write move AX, comma, as 04H. Okay, then I will write move Bx, comma, as 05H. What is this 04? Is the number which I am going to add. Okay, we are writing this number in the form of hexadecimal number, and this is the another number. And using this move mnemonics, I am storing this 04 in the register AX. So after writing this instruction, the AX register will contain 04, and this BX register will contain 05. So, we know the purpose of register is used to store the data temporarily. Okay, either it can store the data or it can store the instruction, address of the instruction. Okay, so after this one, I will write here simply add ADD comma BX. So what it will do? It will add the content of register BX with the content of AX, and the sum will be stored in AX. Okay, so AX plus BX is stored in AX. Okay. Now, okay, you can see writing the code in this form is easier as compared to this one. Okay. So in the machine language, we cannot. It is quite difficult. Initially, the designer were writing their program using this machine language only. However, this assembly language came, and then we started writing the program in this case. Okay, using assembly language, which is higher than the machine language, but this language also comes in the category of low level language. Okay, so if I show the beginning where we are discussing about the two types of language, low level language means machine language, okay, as well as, so this low level language will contain two types, two language, machine language and assembly level language, ALP, assembly language programming. Okay, so both comes under the category of low level language. Then we have high level languages. Okay, in high level languages comes to the category of C, C++, Java, and so on. Now, in this language, it is much easier to write the program. Okay, so let's say that I want to add the two number. So in this case, what I'll write is same case. Int A is 5. Then I'll write int B is 4. Then I'll write here int sum. Okay, int sum, and then I'll write here sum is equals to A plus B. Okay, so you can see in this case you are using almost, I mean, our English language only, vocabulary and grammars that we are using. Okay, I mean, here writing the code is quite easy because it almost you are using English language with vocabularies and grammars. Okay, vocabulary and grammar. So it is quite easy to write the program in this case. Okay. Now let us try to understand the pros and cons of these languages that we have discussed till now. Okay. That is, I will not say that high level language is only the best language or low level language is the worst. Okay. So here there are certain pros and cons for each one. For example, if someone is to write the program in assembly language program, then the user must know about. Just now we people have seen that we are writing something like add ax comma bx. Okay, so you can see a design. I mean, a programmer or user. Okay, programmer or user should know the architecture of the processor. Architecture of the processor should be known to the person. If architecture is known, then only you can write. Why I am saying architecture? Because you should know that which registers are there, and I mean there are many registers to store the data, but which register should be used, or what is the architecture, means whether it is 8-bit architecture or 16-bit architecture. Okay, so we must know about the architecture of the processor. Also, the this language is this ALP is processor specific. Processor specific means the program that we are writing for 8086 processor will not run in 8085 processor. Okay, here this this add AX comma BX will work, but here add AX BX will not work. Here we have another register like add A comma B. Okay, so we have different registers for the each processor. We have different architecture. It is 8-bit architecture. It is 16-bit architecture. It means that it can do addition of two numbers which are of 8-bit. It can do addition of two numbers which are of 16-bit, and so on. So they are processor specific. Okay. Uh, so this is about the assembly language programming, and you can see to write the ALP, a person should be skilled. Skilled means the person should know this architecture, what are the different processor. Okay. However, in the high level language, okay, high level language like your Java, C, okay, Java, C, C++, a person may, so I mean, just need to be semi-skilled. Semi-skilled. The person, even if they are, I mean, a user is not knowing about the architecture of processor, can still write the code. Okay, can still write the program. Just he has to know the syntax and other things about the languages. For example, if he's going to write in the C language, then he must know that he has to define integer type of number whose variable is a, and the value you are assigning is 4. Similarly, another variable which is containing 5 is also of integer type. Then your sum is also integer. Sum is also going to return integer value. Then we are going to define variable sum which is containing a plus b. So here you have to just remember some syntax, okay, and nothing more. You don't need to know whether you are up doing program for 8086 processor or 805 processor and so on. So this is not processor specific. Not processor specific means the program that you are writing in your Dell laptop may also run in the another laptop, let's say HP. Now in this Dell laptop, you might be using any other processor. Okay, I don't know which one. In HP, you might be using different processor because here we know that in motherboard there is a processor. In motherboard we have a processor. Okay, so that processor may be different for this and this. Okay, so this is about the different programming language: high level language, low level language. In low level language we have machine language, and machine language is that language is composed of zeros and ones. Assembly language is having mnemonics which use the combination of alphabets like A, B, C, D, and so on. So this assembly language is little bit higher than machine language. Okay, but both of these comes under the low level language. Then we have this high level language, which is basically using vocabulary and grammars just like English language to write the code. Okay. Now coming to this, we will I mean, before we jump to this architecture of 8051, we'll discuss something more about that how processor works. Okay, how the processor works. So, I mean, just now I gave the example that suppose that you want to write a program to add, let's say I'm writing here ALP, though you are not familiar with this ALP, I'll give in the model 2 we'll see the different instruction set and how to write the program that we'll see. Okay, that is a different model, but let us assume that you're still knowing something, or otherwise I won't be able to explain you what is this, how the processor works. Okay, so suppose that you are going to write program to add two numbers. Okay, LP to add two numbers. Okay, so let's say that you want to perform the addition of 25 plus 45. Okay, so in this case, what you will do is in a 8051, you will see that there are registers like register A, register B, register R0, R1, R2, up to R7. Okay, then we have PC, we have DPTR. Okay, these registers, okay, we'll study about in the next lecture. But using these registers, they are general purpose registers. Okay, general purpose registers which are used to store the data temporarily. GPR, general purpose registers. So this 25 which you have to add, you have to store in some register like let's say A. This number 45 which you are going to add, this also should be stored in the register B. So for this one, I need to use this move mnemonics. So I'll write here move A comma hash. This hash means this is basically pound sign. Okay, so I'll write here 25, and then if you are not writing anything after this 25, then it is decimal number. If you are writing H, then it is hexadecimal number. Similarly, I'll write another mnemonics, okay, as 45H. So by writing this instruction, the A register is now containing 25H, and by writing this instruction, the register B is containing 45H. Okay, and then I will write here add A comma B. Okay, why I'm writing A followed by B? That is all. There is all logic behind this. Okay, that I'll explain to you later on. And then I'll write here end. This our promise end. I'm terminated here. Now, this one you have opened your laptop. You have typed this in the editor window. Okay, that is fine. Okay, now how actually how the processor is going to operate this. Okay, so what is happening in this case? Let's say this is your computer in which you have typed this program. Okay, okay, you have written this all instructions in the editor window here. Okay, this is the editor window where you have written this add, move, and so on. Okay, all this instruction one by one you have written. Now, what is happening? in our computer we have a hard memory. Okay, here we have memory. Okay, so I mean inside the computer we have something called processor. I'm denoting this by processor. Let's say 8086 processor, and then inside this computer we have also something which is called memory chip, memory chip. Now what happens? This instruction, as I said, this is mnemonics. Move is mnemonics, A is the register, and this 25 is the constant number. Okay. So uh, now this assembly language is translated to machine language. Why machine language? Because the processor will not understand these alphabets M, O, V, A, and so on. Must processor understand only zeros and ones. So let's say that this move is having opcode, that is operation code in the form of zeros and ones. Let's say 01100. This is the opcode of move instruction. So this 000, then 1100 is the opcode of add instruction. Okay, similarly we have 25. 25 means 00102, and 5 is 101. Let's say we have here 8 bit, so that this 8 bit is the opcode of add, and this is the value of 25h. Let's similarly we have 45. 45 is 01004, and then 5 is 0101. This is 45h. So this instruction move a comma, all these are translated. Okay, is getting translated in the zeros and ones, and then these zeros and ones are saved in this memory chip. They will be stored in this memory chip in the different locations. These are called locations. These are called locations. In each location, 8-bit data can be stored. Okay, it depends upon your different processor processor. Just let me take another slide here. So here, so what I was saying is that the program that you have written will be stored in this memory chip. Okay, will be stored in this memory chip in the different locations. In each location, 8-bit data can be stored here. Okay, so this is your memory chip. Memory chip. Now here in each location, 8-bit. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So let's say we have taken 0, 0, 0, 1, 1, 0, 0, 0 as the opcode of move A. Similarly, we have another opcode move B. So that will also have 8-bit code. Okay, like this. That 8-bit code will also get stored here. Okay, 101011, something which I'm assuming they have predefined code. The designer has given a standard code binary, zeros ones combinations which are called opcode. Okay, and similarly for add move A, then we have another one, no, move A followed by 45h. So that 45 will be stored here. Okay, that is 45 is. So here in this location, actually 4 should have been stored. Okay, that is 0, 1, 0, 0, and then 5 is 0, 1, 0, 1. This is 45, which is stored here. It's 45h. Then the move B is there. Let's assume that this is the code for move B, 10101010, something like this. Then there is 25 was the number, no, so 25 will be stored here, 1 0, then 0, 1, 0, 1. So like this, all the datas, mnemonics get stored in the memory chip in the form of zeros and ones. And then we have a processor chip. This is another chip which is called processor. Okay, this processor chip and memory chip is connected using electrical wires. Electrical wires. Okay, these electrical wires are called buses. Okay, in the top, from the microprocessor point of view, you have to remember this topology. The buses are basically electrical wires which carries the electrical signal here. Okay, Now, what is happening? The program that you have written is saved here. Okay, that ALP is saved in the memory chip, but the processor is going to perform this addition, that is 25 plus 25. Okay, it is going to do this process, the addition multiply. Whatever processing is actually done by the processor. So for this purpose, this memory chip and this processor is connected using three set of bus. One set of bus is called address bus, okay, which carries the address. Another set of bus is called data bus, which carries the data. I'll tell you what is this data bus control bus, data bus address bus. Then we have third bus, which is called control bus. Okay. All are these electrical wires. The control bus is single wire. Okay, that is 1 bit in the terms of microprocessor. We call 1 bit. The size of control bus is 1 bit. Now this data bus, in this case, let us say that we are discussing about 8051. So in the 8051, the data bus is 8 bit. 8 bit means there will be 8 electrical wires, 1, 2, 3, 4, 5, 6, 7, 8. Uh, Similarly, this address bus size is 16 bit in the case of 8051 microcontroller. 16 bit means 1, 2, 3, 4, 5, 6, 7. Total 16 electrical wires are there. Now, what is happening? See here, uh, there are something. So I was talking about that how microprocessor works. Okay, so the microprocessor works to three uh, phase. The first phase is called opcode phase, of basically fetch. In the second phase it is called decode. In the third phase it is called execute. Let us try to understand this one by one. Fetch, decode, execute. Fetch means acquire. Fetch. Fetch means acquire. Okay. So acquire means these instructions which are saved in the memory chip or the data 45 which is saved in the memory chip will be brought inside the processor, that is called fetch. So how it is done? Fetching is done, see, these are the locations. These are the first, this is first location, second location, third location. Okay. Now each location is assigned certain addresses. Okay. Like the first location may have address like 000H. Okay, let's write here. 000H is the first address. Now this is 16-bit address. You can see I've written 0, 0, 0, and then I've written H. Means it is hexadecimal number. Ideally, this 0 should be 1, 2, 3, 4, 0. Okay, then this 0 should have again 4, 0. So like this, you'll have total 16 zeros. That is the starting address. Okay. Now, just here communication will be taking place between the processor and this memory chip. So communication means, for the communication, there should be some addresses. For example, a postman has to deliver or receive address from your house. So what is the step? The processor will start from the post office. He is supposed to know the address of your house in your colony. Let's say your house number is 45. Okay, so he will come in that let's say this colony, and in that colony is going to find the house number 45. After coming reaching your house number 45, he is going to either deliver the letter or receive the letter and come back to the post office. Okay, so the same analogy is here also in the between the processor and this memory chip. So here the designer has designed this to, I mean, whatever I'm explaining is actually programmed. Okay, the designer has programmed this processor to do this fetch, decode, execute. Okay, automatically with respect to clock signal. Okay, we people are not interfering here or doing this fetching, decoding. Everything is done by the processor and that is programmed by the designer. Okay, so they have designed it in such a way that this one by one step will take place. So in the first step, this address will be this address from where our first instruction has to be brought inside the processor will be loaded by this processor. So if that address is stored in this PC register, PC is program counter register which points to the address of the instruction from where the instruction has to be fetched. So what is the starting address? 000H. This address will be loaded on the PC. From PC, this address goes to the address bus. So this 16-bit 16 electrical wires will carry the 16 bits 0, 0, 0, 0, 0, 16 zeros. Okay, this is the address, and this address bus is unidirectional. Okay, unidirectional means address is also always going from processor to the memory chip. Okay, so that address, this address is loaded from the PC to the address bus. Once this address is received by the memory chip is not knowing what has to be done. Okay, so in this case, the if now in this case, what is the operation that has to be done is memory read. Okay, so memory read means it is going to read something from the memory chip. So for that purpose, this control bus is there. So in this control bus, the processor will send a memory read control signal. So memory read control, as I said, everything is in the form of zeros and ones. Okay. So this memory read is again zero. If it is, let's say in the short, it is MEMR, and you see this bar is there, and it is actually zero. It is active for zero. So a zero is sent from the processor to this memory chip. As soon as a zero is received here by the memory chip, the memory chip will know that it is memory read signal, and the processor wants to read something from the address that was sent in the step 1. So after receiving this memory read signal, the processor will load this instruction binary code on the data bus, which is 8-bit. Okay, so that 8-bit data will be loaded on this data bus, and it will be brought inside the processor. So here this instruction has been brought. Okay, this instruction has been brought, which is saved in instruction register. In the instruction register, it will be saved and it will goes to the decoder circuit. Inside the processor, we have decoder circuit. The decoder circuit will now this fetch operation is done. Fetch means acquire the instruction. After acquiring the instruction, it is stored in the instruction register. Now the second operation is decode. So for the decode, this instruction from the instruction register goes to the decoder circuit. Decoder circuit will decode it. Decode means interpret the meaning. As you can see, it is in the form of zeros and ones. Zeros and ones. So after interpretation or finding the meaning, it will understand that it is move A instruction. Okay, move A opcode is there. So this is called decode. Okay, after decode, it will convert. It will know exactly what is the role. I mean, what is to be done here. Then in the second step is, third last step is execute. Execute means you recall the instruction move A comma has 45 watts by 545 watts. So here execution means this 45 will be stored in the A. So this A will be stored with the value of 45 as this is execution. Okay, so there are three steps. The first step is the instruction will be fetched from the memory chip, brought inside the processor. In the second step, the instruction will be decoded by the decoder circuit. In the third step, once the instruction has been decoded, the execution will occur here. So execution is, differ from instructions to instruction. For example, if it is move A comma 45h as 45h, then 45 is stored in the A. Suppose that it is add A comma B, so in that case execution is A plus B. Okay, that execution is different for the different instruction. Okay, so like this we have three operation which is fetch, decode, execute. Okay, uh, so this actually occurs according to the clock signal, that is the timing is there. So for this timing purpose, we'll understand this in the next class, and then we'll also try to understand this architecture of 8051 microcontroller. Okay, so once we have understood all these things, then architecture is not difficult to understand. Okay, so in the next class, I will discuss about this timing diagram, and then we'll continue to the architecture of 8051. So thank you everyone.